Founding moment for me was coming off of some commercial success that we had deploying AI and computer vision in airports. In that type of environment, you have a bunch of different stakeholders, and they're not necessarily all aligned. And typically, that actually had been an environment that had friction before AI was introduced. As soon as you add automation into the mix, I think the stakes become a little bit higher. Individual stakeholders are held accountable with service level agreements, and they're gauged by the performance and metrics of those agreements. When those contracts are established, they're established with different goals and incentives aligned. One might be a service provider working for a particular airline, which the metrics don't necessarily line up with a competing airline or the airport's operation overall. So with AI being deployed across all these different surfaces of technology, and you have all these vendors, everybody is pushing the forefront for state-of-the-art, how we can kind of introduce new efficiencies. You have a mixed environment where, say, an airport authority does not have the ability to gauge through logging or auditability, because a lot of this data and these logs and these performance metrics are actually secured behind some sort of firewall. That particular vendor, SaaS, service provider, they all have that information locked away, and honestly, like, logs can be tampered with. In fact, that was a lot of the feedback in that particular environment. An airport actually needed to bring in a third-party auditor to assess the situation. They just couldn't make heads or tails. So when we kind of saw that there was this major challenge with really identifying performance with all this type of automation, you had a need, and that became the genesis story for Inference Labs. Like, if you kind of look at humans per se and how we interact with technology, we've essentially used biometrics. We have used, started off with Fingerprints, Touch ID, for as an Apple product, or Face ID. There's some sort of biometrics involved in how we interact with technology. Those primitives don't necessarily exist for artificial intelligence or autonomous systems, robotics. There is only the manufacturer, they're providing the firmware. There might be some logging in the form of like a text file, but there is no way to ensure that that isn't tampered with until now. And essentially what we are working on is the ability to provide that auditability, provide the fingerprints on that autonomy, and essentially provide like those guardrails. We kind of look at ourselves as like that physics layer where it's not necessarily how the model was trained, but we're able to define the rule set. If that particular model cannot pass that cryptographic proof, then it cannot perform those actions. And that's the aha moment, I believe, that kind of really resonates with a lot of people. Might be a little bit cliche to say we're early in Web3, but we are when it comes to ZKML. I think there's a tremendous amount of opportunity here. We have a ways to go. We recently were invited down to Google's ZK Summit as an intimate gathering, really academics, infrastructure, people doing research, as well as like Web3 projects. And we're starting to see, like, ZK being used in production, L2s, 4 or 5 years ago. Beyond that, it was like more theory and trying to find an application for it. Now we are actually seeing it used in production. We're seeing proving times almost atomic. We're able to kind of keep up with blocks being generated. But in that environment, right, you look at L2s, like blocks themselves are kilobytes in size. And with ZKML, we're comparing that to AI models that are gigabytes in size or terabytes in size for some of these monolithic frontier models. So there's still a ways to go because some of those larger models, they're just unable to circuitize them, prove them. They're just too large. There just isn't enough computational hardware to do that until recently. Some of our amazing research team here at Inference Labs was able to come up with a novel approach which slice up the model with DSperse. And typically when people talk about decentralized AI, it is this idea and thought of taking a model and distributing it to non-centralized nodes and have them run these models. I think the challenge with that is that you can't guarantee that those operators are going to run the models as instructed, or there's a possibility based on incentive design or something like that for malicious actors to misbehave because the cost of running this computation is quite expensive. So if you can do it and produce an inference with much less compute hardware but gain the same reward, you're incentivized to do so. So by allowing us to kind of release, or by allowing these operators to slice up these models and distribute them, there is some cryptographic guarantees that that particular computation must be executed as intended. So really exciting development there, as well as JSTprove, which is a GKR-based toolkit. It's really going to streamline things for a lot of developers. It's really exciting. The benchmarks look very promising. Both the GitHub repos are available now. But in the next 3 to 5 years, I think it's really exciting because us being a second order problem that we're solving is that you kind of see it everywhere. Everyone sees it. Log into whatever SaaS. There's AI, something being kind of shoved down people's throats. But I think that's the exciting opportunity there is people are experimenting, trying different things. But it does create like this problem, which is primarily what we're solving, and that is you have this environment where it's going to be heterogeneous. You have mixed vendors, let's say in an enterprise setting, and they're all going to be leveraging their own predictions, own inference, own products and services. And the challenge is that in that type of environment, it's hard to audit that. It's hard because there is no real kind of like forensics, auditability that is available to these customers, and all they're going to see is just like these metrics that this automation is performing at this level, and if there's a failure, it's very hard to trace that out across multiple vendors. I've been in a commercial setting, which we're exploring in civil aviation for winter operations, where an airport themselves had to actually bring in a third-party auditor to help assess like where failures or successes are happening behind these firewalls between all these different vendors. And what we're doing with Inference Labs is codifying that, allowing the ability for these vendors to still maintain their IP and protect their IP of these particular models, but at the same time provided this assurance for this mixed environment that there is auditability, there is the ability, if something does happen, the ability to kind of track that down and trace it out. So lots of areas to kind of explore. We're very excited about this space, both from a technology standpoint and a commercialization one. That's a really good question. It's more of a personal one. I've been an entrepreneur for many decades now, and had the fortunate opportunity to hire some great people, working with all sorts of people. Even before COVID, we had a distributed team. I was able to kind of manage a team that was globally distributed on every single continent on Earth, with the exception of Antarctica. Very lucky to meet and work with some really great people. I think with AI, recently, you have this cat and mouse game. You have employers that are able to screen candidates with AI tools. You have candidates leveraging AI tools to help present. And I think fundamentally, when you kind of break down a lot of those layers, in the past, a lot of people would be judged on their level of intelligence based on their communication skills. And that is good and bad in certain ways, because obviously there was a massive subset of people that were highly intelligent, that might not speak English, or English was a second language, and automatically the mind is very capable of making decisions very quickly based on communication skills. And I think fundamentally what's changed is that now everybody, even the open source models, forget the frontier models, everybody basically now has PhD level reasoning available to them, just at their fingerprints and fingertips, and that technology is only going to improve. So what ends up happening is that you commoditize those communication skills. We leverage LLMs every day right now. So I think for me, it is finding a candidate with a very strong sense of human agency, the ability to absorb and understand their environment and the changing environment, and be able to react and make decisions based on the changes to that particular environment. And I think human agency is going to be something very difficult to duplicate, even with AGI. So I see that being a path where it can be very synergistic with humans and multi-agent systems.